Subscribe our channel and press the bell icon for watching more video.
Hi there! In this section, we will start talking about modules. One of the reasons why Python is such a powerful language is that, for pretty much any task you want to accomplish, if there isn't a way of doing it with Python's core functions, there's a high probability that there will be a module providing all the tools you need to achieve what you want. In the previous sections, we already used some interesting built-in modules like the random and the math modules. I will show you a few more and also some really powerful external modules which we can easily install and start using. In this lesson, we will start with the time module. We can import it by typing import time. If you import a module that has a big name, instead of just typing import and the name of the module, you can use the keyword as, and then you can pick a different name, which will be the one you're gonna call later. So in this case, I'm going to import time, and I'm going to use the name t. This module provides a few useful functions to work with date and time. Let's start by getting the current date. So I can just type t, which is the name I just chose, dot local time, open and close parentheses. What we see here is the exact time right now when I'm recording this video. So we have year, month, day, hours, minutes, seconds. We have the weekday, the year day, and the 0 means I'm not currently on daylight savings time. As you can see, today is Wednesday, January 2nd, 2019, and right now it is 7:07 p.m. 2 for the weekday stands for Wednesday. And how do I know it? You can see the documentation by going to Google and typing Python time module. When you're searching for documentation, make sure you pick the right version. So this one here is for Python 2.7. So the right one for me is going to be Python 3.7. Now let's search for TMW day. There's one result here. And now we can see that TMW day is a range from 0 to 6, where Monday is 0. So this is where I found that 2 stands for Wednesday. Now let's say a user is doing a transaction in our program and we want to print a message with the exact time of the transaction. We can create a variable called time now. And then we are going to store the current time. Now we could print something like transaction completed at, then I'm going to get the current hours, and this is a number, so I have to convert it to string using the str function. Now we can use the dot notation to get specific values. So timenow.tm hour. Now we can concatenate with an age. And now we can get another information, but this time we want tm min. And now we're going to concatenate with an m. Let's see what we got here. So by doing this, we are able to use the current time in our program. Now let me show you another interesting thing we can get from the time module. We got in return this weird number, and if I keep repeating the same code, we can see that the number is increasing. So 752, 764, now 770, 775. So what is this number? This is a timestamp. It shows the number of seconds that have passed since the epoch. The epoch is something important in any programming language. It represents the point where time starts. Python uses the Unix epoch, which is January 1st, 1970 at 0 hours, 0 minutes, and 0 seconds. So what we have here is the exact number of seconds elapsed since that day. Why is it useful to have this information? If you want to make calculations with dates, it is very easy to do it with timestamps. Let's say a product takes 7 days to be delivered, and I want to tell the user when he's going to receive it. If I try to get the month day from local time and add 7, it is going to be hard. Let's suppose today was the 26th, so the sum would result in 33. I would need to write a very complex function to return the correct day and month. But if we use timestamps, it is really easy. So let's get the time now. And let's get the delivery time, which is just going to be time now plus the number of seconds in 7 days. If you're not sure how to do it, just go to Google and type number of seconds in 1 day. So here we have it, 86,400. So 86,400 for 1 day, but we want to add 7 days. So let's multiply it by 7. As we just saw, if we use the local time function without any argument, it's going to get the current time. But we can also use that function by passing a timestamp as an argument. So what we have here is a timestamp that we just calculated. So if we do this, we have all the information about the delivery day, which is going to be January 9th, 2019. So now we have the correct delivery date without having to write a crazy function to calculate it. You can then get any information you want from here and output it to the user in the format you want. Another interesting function from the time module is the sleep function. It is used to delay the execution of the next line of code. So if I use t.sleep, I can pass an argument which is going to be the number of seconds. So let's pass 5 seconds. As you can see, nothing happened here. And just after 5 seconds, I'm able to write code again. If we had used it in our program, the next line of code after this one would have been executed after 5 seconds. So for example, I could use it to make a countdown timer. Alright, so this was all I wanted to talk about the time module for the moment. If you want, you can learn a bit more by going to the documentation I just showed you. If you have any questions, just leave it in the Q&A section. I'll see you in the next video. In this lesson, we will talk about the Matplotlib module, which is used to make charts in Python. Matplotlib is an external module. That means we need to install it before we can import it into our program. Before we do it, let me show you a few interesting external modules for Python. So here I have some examples. This one is called requests. This is a module used to do HTTP requests in Python. We are going to explore it a bit later in the course. Almost every module is going to have a web page like this showing you how to install it and use it. So this is the web page for the requests module. Here I have WXPython, which is used to create graphic interface for your Python programs. If you want to work with SQL databases, you could use the SQL Alchemy module. This one is called SciPy, which is a library of algorithms and mathematical tools for scientific calculations. This one is called Pygame, which is used to create games in Python. And the last one I want to show you is called scikit-learn, which is used to do machine learning in Python. We are also going to explore this module a bit later in the course. So those are only a few interesting examples I wanted to show you. But like I said before, for pretty much anything you want to do with Python, there will be a module to help you. So now let's see how easy it is to install a module and start using. Let's go to the command line. I just press Command spacebar and I'm going to look for the terminal. On Windows, you can just press the Windows key plus R and then type cmd. Now let's install Matplotlib, which is going to be the first external module we are going to use. So we just need to type pip install and then the name of the module, so Matplotlib. Pip is a package manager for Python that comes with the Python installation. So when we installed Python in our computer, one of those options that were checked by default was the pip installation. So if I press enter, in my case, it just tried to install a few things and told me that the requirement was already satisfied. This is because I already have Matplotlib installed in my computer. In your case, you should see the progress of the installation. Now we can import it here, just like the internal modules. So let's import Matplotlib, and Matplotlib has some sub-modules. For this lesson, we are going to use pyplot. So matplotlib.pyplot. Let's just call it PLT. Now let's create a simple chart by using two lists of values for X and Y axis. So X is going to be a list. I'm just going to put 1, 2, 3, 4. And Y is also going to be a list, which must have the same length as the previous list. So I'll just put some numbers here. Now we can use the plot function, which is going to be plt.plot, which is going to accept two arguments, which are the lists of values for the X and Y axis. Now, if you want to see it, you can just type plt.show. And now we can see our chart. So this is how we generate a chart from two lists of values. The two lists have to be numeric, but we can assign a legend to the values. So let's create another list called legend. And now instead of 1, 2, 3, 4, let's write the months. Now we can use a function called xsticks, which is going to assign to X the legend we just created. Now let's run the plot function again, so plt.plot. And now plt.show. Now we just replaced our numeric values with strings. The chart we did was a plot. You can check the documentation to see how can you do other types of charts. So let's just go to the Matplotlib page. I don't know if you noticed, but Matplotlib is also part of the SciPy module. So we could have just installed SciPy, but in this case, we installed just Matplotlib because this is the only one we're going to use it for now. So I can just click here and then go to examples. And then you can see that you have many types of charts you can do with Matplotlib. So let's just try another one. Let's use the same lists of values, but this time let's use the bar function. So plt.bar x and y. We can also add some labels to our chart. So let's use plt.ylabel. So let's say this chart is for sales in US dollars. And let's also include a title for this chart. So plt.title. Let's say monthly sales. Now let's write plt.show again. So now we have a bar chart with the same lists of values. If you want, you can further explore Matplotlib in the documentation page I just showed you. For now, that was all. I'll see you in the next video. Hi there! It's time to exercise what we just learned about the time and the pyplot modules. Create a program to help the user type faster. Give him a word and ask him to write it 5 times. At each time, check how many seconds it took the user to type the word. At the end of 5 rounds, show how many mistakes were made and print a chart to show the user's evolution. Good luck! And when you're finished, go back here to see the solution. So the first thing we need to do is import the modules we need for this exercise. So matplotlib.pyplot and time. Since we're going to have to do a chart with the times, we know we're going to need a list of the times. So let's create one. So times equals an empty list. Let's also create a variable to store the number of mistakes. So now we are ready to start our program. So let's tell the user what this is about. This program will help you type faster. You have to type the word programming as fast as you can for 5 times. If you want, you can choose a different word. Now let's create an input just so the user has to press enter before we start getting the times. So let's write press enter to continue. We don't want to get anything from this input, so we don't need to create a variable. Now the first thing we're going to do is create a while loop. And let's get the length of the times list. At this moment, it is an empty list, so its length is 0. So while len times is less than 5, let's do t.time to get the start time as a timestamp, which we know is the number of seconds since the epoch. Now let's create a variable for the word. We are only creating a variable because we want to test if the user made a mistake or not. Otherwise, we would just need to have an input. Let's write type the word. Now, after he finishes, let's get the end time with t.time again. And now time elapsed, it's going to be end minus start. So we would have the number of seconds taken to write the word. Now, at each iteration of this loop, we are going to send the time elapsed to the times list. So times dot append time elapsed. We should also check if a mistake was made. So if word, let's convert it to lowercase so we don't have problems if the user uses some capital letters. So word.lower, if this is not equal to programming, then we are going to do mistakes equals mistakes plus 1. So now we are ready to end this loop. So after 5 times, the first thing we're going to do is print how many mistakes were made. So let's write you made, then let's concatenate with the number of mistakes converted to string. Now let's print. Now let's see your evolution. And then instead of showing the chart immediately, let's wait 3 seconds so the user can read these sentences. So t.sleep 3. Now let's create a list for the attempts, which is going to be the x-axis. For the y-axis, we can just use our times list. Now let's do plt.plot with our x and y variables and plt.show. And let's see if this is working. Let's save it and press F5 to run it. So this is not starting until we hit enter. This is because we use the input. Let's make a mistake here. And it's telling me that I made 1 mistake. I can see a problem with this as here, which we can solve just by putting it inside parentheses. So it doesn't matter if it's 1 mistake or more than 1 mistake. And now we also have an error because I just typed plot instead of plt. So it's not plot, it's plt. And now let's just put it inside parentheses. And this is going to be better. Let's run it again. Let's make 1 mistake here. Now I made 1 mistake. It waited 3 seconds. And now it's showing me the evolution, which is really cool. But now let's make this a bit better. Instead of having integers for the x-axis, let's create a list called legend. And let's use strings so we don't have those 1.5, 2.5 in between. So plt.xticks, the arguments are x and legend. Let's also create x and y labels. So plt.ylabel, which is going to be the time in seconds. And let's also do the x label, which is going to be the number of attempts. Now let's just create a title for this chart, which can be your typing evolution. I think this will be much better. So let's save it and press F5 to run. Now I made 0 mistakes, and here I can see my evolution. So now this is a little better. We have a chart with a title, we have a label for the y-axis, and a label for the x-axis. We also transform the values into strings, so we don't have those numbers in between. So this was the solution for this exercise. I hope you enjoy doing it, and if you have any questions, you can leave it in the Q&A section. I'll see you in the next video.